All right, welcome back, and today we're going to have a look at the graphs of circles. Now, for people who were in my class last year, we did touch on this a little bit, but I'll quickly go over the idea behind it. I won't spend too long because it's not hugely necessary. All right, so first of all, the idea is that there's a point P, which is at a location of x, y. So x, y. This is a graph of it here. This is the y value, this is the x value. So x is the horizontal distance from the origin and y is the vertical distance from the origin. All right. Now, we're interested, for whatever reason, in finding out how far the point is from the origin. All right. So we're going to use our distance formula to do that. And our distance formula just runs off the back of Pythagoras. So it's going to be in the form of a squared equals b squared plus c squared. So I'll substitute in the terms that we're using, so that's distance. So distance squared equals x squared plus y squared. All right. Then if we're interested in finding distance, we would just square root that. But I'll leave it like that, and I'll show you why. Because let's imagine that this point, instead of being here where it was somewhere like down here, and this is a different point. All right, so we've got a vertical distance from the origin and a horizontal distance from the origin, and we've got a diagonal distance from the origin. All right, and we would use the same process to find that out, to find out the distance. We would use exactly the same formula. All right, so then this means that if there is a series or a set of points that are all the same distance from 0, 0, that then this blue equation here could be an example of their equation, how to find all of them. All right, if they're all the same distance, then the distance formula will be the same for all of them, all right, because that distance is locked. Will be the same. For instance, we might say that all of them are 1 unit away from the origin. So this would be their formula, x squared plus y squared. All right, so anything that adds, any value you can put in place of x and y and add up to make 1 could be a possible location for the points. All right, it could also look like it could be 3 equals x squared plus y squared. It could be any number in this position, because this equation here is a series of points that are all the same distance from 0, 0. All right, so then this means that this is effectively the equation for a circle, because a circle is a set of points that are all the same distance from 0, 0. So we've just modified Pythagoras to help us and come across the formula for a circle. All right, so lock this away. A circle, the formula is, I won't use D because a feature of the circle is r squared equals x squared plus y squared. And it has to be r, and I used D up here because that stood for distance, but if I was to use D down here, it would stand for diameter because I'm talking about a circle. And the only thing we've done here is that they're identified the points all have to be the same distance. And that same distance is this diagonal dotted line here, and that is clearly not diameter, it's radius. So this, when you rewrite the formula for equation of a circle, it has to be r equals and not d equals. All right, so the equation for a circle is r squared equals x squared plus y squared. All right, and we'll go through a few transformations in a minute, but that's the basic form. All right, now to talk about a few transformations. So the regular graph, or the basic graph of a circle, is centered at the origin and it has a radius of 1. All right, don't ask me why it's 1 and not half or anything like that. I think 1 is just the easiest for us to work off. So it's just, and this is going to be terrible graphing, it's just drawing the quarters like that. So then this distance here is 1, and down is 1, and so on. All right. Now, every other graph is said to be a transformation of that basic graph. All right. And the transformations occur like this. So with r squared, you can leave it as radius because we always like to see the r squared on the left-hand side, or at least by itself, not with the x and y terms. Then you're going to see brackets in here. Horizontal translation, of course, occurs next to the, or with the x value. Vertical translation occurs with the y value. All right, so same letters mean the same thing. This is horizontal, and this is vertical. And I've just made a mistake in there, so I'll fix it up. You might have noticed that I put a plus sign there. That should be a minus sign. All right. So notice again that because of those minus signs in there, you have to read the opposite transformation. Have to be read as opposite. So if the graph had been moved 2 units to the right horizontally, this would be read as -2. So it would look as x minus 2 squared. This would be read as 2 units to the right because that negative sign is embedded into the equation. All right, so I'll just erase that for now, and we'll have a look at a couple of examples. All right, so example 1 says to write the equation of a circle that has a center at point -3, 5 and a radius of 2. All right, so we're just going to plug these values into the formula for a circle. All right, so first of all, the center. So the center we can read as horizontal translation and vertical translation. All right, so think about this center of the original circle being moved 3 units to the left and 5 units up. All right, so keep that in the back of your mind. We're going to see it's going to be x minus -3 squared plus y minus 5 squared. All right, now we have to simplify the x minus -3 to become x plus 3 squared. Y can just stay as -5 squared. And the final step is to plug in this value of r. Now it says the basic formula is r squared, so we're going to have to square whatever r value we know, so it becomes 4. All right. Another way, if you don't want to write 4, you could write 2 squared, and that means you can read, straight off this equation here, you can read the r value is 2, the translation is 3, or 3 left and 5 up. All right. Keep in mind, these have to be read as the opposites of what you write into the brackets because those negatives are embedded into the formula.